This lesson is going to help you determine if a relation is a function. We have already discussed what a relation is and the various ways that a relation can be represented. So today we're really focusing on the function part. And so let's define function. A function is a relation where every input has exactly one output. Where every input, every value of the domain has exactly one value of the range. And we can go back to our function machine to kind of show a very clear example of what this means. Is this a function? Well, does every input, here our input is x equals 4, and our output is y equals 11. If I plug this 4 in, the only number I can get is 11. There's no way my input can give me anything other than my output. So this has to be a function. Now, we only tested one number. So for this one example, this x equals 4 and this y equals 11, it works. But what happens when we have more than one input? We have to check all those inputs can only give us one output. So moving on, we already discussed that relations can be shown in these 4 ways. They can be shown as ordered pairs, tables, graphs, or mapping diagrams. Now, in order to determine whether these 4 things are functions or not, we really only need to know how to do 2 things. To determine whether an ordered pair or whether a table is a function, we need to use a mapping diagram. Because this is the clearest way for us to see whether it's a function or not. And obviously, for the 4th one, mapping diagram, we're going to use a mapping diagram. So for 3 of the 4, we use a mapping diagram. And for graphs, we use something called a vertical line test. And so we're going to talk about what this looks like in a little bit more detail. So in example 1, they want to know, is this a function? They've given us these ordered pairs. Again, we can call these relations. And a relation is something that relates an input to an output. So again, input being an x, output being a y. X is usually represented by domain, y is our range. Just different words for all of the same thing. So, is this a function? Well, going back, they said using a list of ordered pairs, we need to draw a mapping diagram to determine whether it's a function or not. So in a mapping diagram, we're just going to draw some boxes for our domain, our input values, some boxes for our range, our output values. And we're going to put all of our x's, or our domain, and all of our y's in the boxes. So here's our domain and our range. We have a -4, a -1, a +1, and then again in this we see we have another +1. Since that's already in our box, we don't want to write that twice. So we move on, and the last value is 2. Then we have our y's. We have 2, -3, 4, -3, and 1. And again, because we have 2 repeats here, we really just want to write it once. We don't want to repeat any values. It's just going to make things confusing for us. So once we write everything down, we really need to go back and check and see, do I have any repeats? And if you did like I did, just erase and make sure you get rid of it. And now we want to draw our arrows, our mapping diagram. So sometimes this is drawn in for us, but when we're creating our own, we need to draw the arrows in ourselves. So I know that -4 needs to go to +2. Here we go. -4 needs to go to +2. I know that -1 needs to go to -3. 1 needs to go to 4. And 1 also needs to go to -3. And 2 needs to go to 1. So if we think back to the definition of a function, they want to know, is this a function? Well, we know that a function means every input with exactly one output. Right, so this goes back to the idea of our function machine, that when I put something in, I should only get one thing out. So if we think of this first ordered pair, I'm putting in -4 and I'm getting out 2. And I can see that here looking at my arrow in my mapping diagram. I'm putting in a 4 and I'm getting out a 2. My input has exactly one output. So that one works. -1 to -3. So -1 goes to -3. My input has exactly one output. So -1 gives me just -3. That's okay. So let's check my next ordered pair. 1 and 4. 1 to 4. So my 1 gives me a 4. That looks okay. But I also see that 1 gives me a -3. So they're saying that this one input is giving me a 4 and a -3. Can this exist in a function? Not according to the definition. Here, every input, the input being a 1, has more than one output. This is not a function. And the reason it's not a function is exactly because this number 1. It's screwing everything up because this function machine cannot happen. This is impossible. I can't have a function machine that has one input giving me 2 numbers. And if we think back to our machine here, there's no way that I can plug one number in and get 2 things out. If I'm doing the math, it's just not possible. And so what this is saying is that the math is giving me 2 numbers, which we know can't work. So no, this is not a function. And if they ask why, we would have to say something along the lines of what we just showed in this diagram. 1, oops, that's not a negative. 1 has more than one output, which is impossible. Right? Based on the definition of a function. So, here, the big mistake that commonly happens, our common error, is that we forget to write our repeated numbers as one thing. Right? So a common error is we forget to combine repeated numbers, right, in the mapping diagram. Right? And if you forget to combine the repeated numbers, sometimes you get a box where if I wrote 1 twice, and I wrote 4 and -3, and I wrote -3 again, it seems like everything is matching up and it's just going to exactly one number, and so it's hard to see this problem of the one input going to two places. If we rewrite it twice, it's not as obvious that this one input is really the same thing, even though it looks like this one is going to one output and this input is going to one output. It's actually not, because this is the same thing. So we really want to make sure that we're not forgetting to combine those repeated numbers, because this is a really easy way to accidentally call something a function when it's not. Alright, let's look at another example. And here we have the question, is it a function? And we're given a table. And again, going back, we know that a table is going to use a mapping diagram to make it more obvious for us whether it is in fact a function or not. So once again, we go to drawing our input and output boxes, and we write our values in, again checking for those repeated values because we don't want to make that mistake. So our 5, our 10, our 15, and our 20. And here we have 20, a repeated value, so I don't need to write that again, 30, and a repeated value, so I don't need to write that again. And so we want to match our x and our y's according to our table. So again, I know that 5 needs to match up with 20, 10 needs to match up with 20, 15 needs to match up with 30, and 20 needs to match up with 30. So we've drawn our mapping diagram, and now we need to analyze this and make sense of it. Again, think back. What does function mean? That the input has exactly one output. Alright, so we gotta keep that in the back of our mind. Alright, so 5 is my input. Does it have one and only one output? Yes. Alright, 5 is giving me 20. It's not going to more than one place. Does 10 have exactly one output? Yes, I'm plugging one thing in and I'm getting exactly one thing out. I need to check 15. Does 15 have one output? Yes, it does. Does 20 have one output? Yes, it does. Right, now this can be confusing because we're like, okay, well in the last one, anything that had 2 arrows wasn't, and now it is. Right? You have to think about the definition. In the last example, we had one thing going 2 places. Now here we have 2 things going to one place. That's okay, because again, it's following the definition of a function, that this one thing is going to this one thing. And again, if we think of it in terms of our function boxes, all right, 5 came in, 20 came out, 10 went in, and 20 went out. Right? We're not having one number give us 2 things. That's a problem. But 2 different numbers can give us the same thing. That's okay. Right? So, yes, this is a function. Because every single input has one and only one output. Right? And yes, this is okay, and this is okay. Alright, let's look at another example. Now here we have, they're just giving us mapping diagrams. And again, we can go back to the very beginning where a mapping diagram is just going to use the mapping diagram. It's what we've been using for ordered pairs and tables, so we can use it for mapping diagrams as well. Sometimes it'll just be given to us. Sometimes they are something that we have to create. So we need to be able to look at this and understand it. Alright, so let's think about this and see if we can make sense. Is it a function? Well, 5 goes just to 2. 3 goes only one place. 1 goes only one place. And 2 goes only one place. So this would be an example of a function. Alright, now let's look here. -1 is going to 2, and it's going to -1. Right? Already, we can see this one input has more than one output, and that's a problem. Right? We also see that 5 is going to 4 and -3. So we have lots of problems going on here. Right? Again, we can't plug in one number into the machine and two of them that are different come out. We can't plug a 5 and get two different numbers. So this is not a function. So as long as we know the definition of a function means that one input can have only one output, that's okay. Now this can be confusing because over here, well, we have this going on, and it seems like two arrows are going to that. That's confusing, right? An easy way to think of this is that all of this math is a big party. Alright, so over here we've got a key point. Alright, math is a party. Who knew? Alright, so this is the easiest way to remember functions. That math is a party. Alright, one person cannot be at two parties at once. So here are your people, and here are your parties. Alright, this -1 is trying to go to the 2 party and the -1 party. Alright, one person can't be in two places at once. Right? It's not possible. This guy can't go to both parties at the same time. He has to just pick one. Alright, so that's fine. -5 is going to this party. -3 is going to this party. 1 is going to this party. And guess what? 2 is also going to this party. That's fine. More than one person can go to the same party. Wouldn't be much of a party. This is not a very fun party. Only one person's going. That's okay. Alright? So, two people, two or more, can go to the same party. Alright? So this is an easier way to remember it because we can relate it to our lives, right? One person can't go to more than one party, but two people can go to the same party. So we want to have a lot of people going to a party to make it interesting. So yeah, he can go, and he can go, and they can go, and they can go, and we can have everyone going to this party. And if we go back and look at our examples, right here, when we said, yes, this is a function, because we had both of these people going to the same party. That's okay. Both of these people are going to the same party. That's okay. But here, it was a problem because this guy was trying to go to two parties at the same time, which isn't allowed. Right? So, hopefully that helps us remember, but as long as you know the definition of a function, you should be able to figure it out. Right? And the last way is using a graph. How do we determine whether it's a function or not? And we could use logic, but they also have this nice little shortcut for us, which is called the vertical line test. Alright? The vertical line test is exactly what it sounds like. It's a vertical line. Alright, so here we have a vertical line. Vertical line is an up and down line. Right? If we drag the vertical line across our graph, it should only hit in one point. So here I put my vertical line anywhere, and it's just hitting the green graph at that one point. If I move it over, it's still just hitting the green graph at exactly 1 point. At exactly 1 point. So if I draw all these vertical lines in, it doesn't matter where my vertical line moves, I'm only hitting at this point, this point, this point, this point, which means that every x, this x, this x value, this x value, this x value, is giving me 1y, 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 1y. So when I plug in this x, I get out this y. When I plug in this x, I get out this y. Right? It's just one point of contact, so yes, the vertical line test passes. Because everywhere the vertical line test touches, it's just touching in one place. Right? Now let's test it over here. So I have my vertical line, and I'm saying for this x, I should only be getting 1y. My one input should be giving me one output, but what am I seeing? This vertical line is touching in 2 places. So my one input is giving me 2 outputs. We know that can't happen, right? And there's a bunch of these tests. If I move my vertical line anywhere, it continues to be a problem. And my 1x, this input x, is giving me this number coming out of the function and this number coming out of the function. So again, here my function machine, I'm plugging in 1x, and I'm getting out 2y's. This can't happen. So this is not a function. No, not a function. Alright, so here are a bunch of different ways for us to tell whether we have a function or not. Again, the key point is truly understanding that the function is just like our function machine, that only one input can give us one output. There's no way for the math to work out that this 4 is going to give me 11 and some other number. So if we really understand what a function is, all of these examples should make sense. It's just a different way of looking at the same idea. Alright, make sure you're writing any questions that you have in your notes so that you're ready to discuss tomorrow.